Salam everyone. I hope you are doing well. Sorry for late today. I was in the university. I was coming back from the university. I hope you are doing well. Our today lecture is the whole about reconfigurable antennas. Okay, or switchable antennas. Okay. I am waiting for the other participant. They did not join yet. There were less members here. Okay, we start the session. I hope they will join very soon. We don't want to be very late. Okay, so our lecture is on reconfigurable antennas. Okay, yesterday we discussed that reconfigurable antennas are of three types. Okay, reconfigurable or switchable. Reconfigurable. Okay, reconfigurable or switchable. Okay, switchable antennas are of three types. Okay, the first one, it can be of frequency reconfigurable. Okay, it can be of frequency reconfigurable, like if you have your switch is on, like if your switch is on, you can say my frequency is my antenna is working at like 1.2 gigahertz. Okay, and if my switch is off, then it is working at 900 megahertz. Okay, so if it is shifting the frequency band, then you can say this your antenna is switchable, reconfigurable, frequency reconfigurable antenna. Okay, and the other type of the reconfigurable is the pattern reconfigurable. Okay, pattern reconfigurable antenna. Okay, suppose if your switch is on and your antenna is behaving like a omnidirectional radiation pattern. Okay, but if your switch is off, like it works or behaves like a directional radiation pattern. Oh, sorry, yes, directional or bidirectional radiation pattern. Okay, or it can be broad-sided or left-sided. Okay, directional radiation pattern. The other one is the polarization. Okay, polarization reconfigurable antenna. In this case, suppose if you have if your switch is on, your antenna is working as a like a circularly polarized CP antenna. Okay, if your antenna, if your switch is off, then it is working as a linear polarized antenna. Okay, so we have three cases. Okay, if we can target any of the frequency, I mean any of the case, or if we are able to I mean target all the three cases, then we can say we have achieved a lot of novelties. Okay, even if you can able to work on frequency reconfigurable, it is okay. If you want to work on pattern reconfigurable, you can try. Okay, you will see all these things. Okay, if you have achieved any of them, then you can claim that your antenna is a reconfigurable antenna. Okay. So for the diodes, I mean for the switches, what we use here, here in simulation, you can use what you want. Okay, but in the case of the, I mean if you want to fabricate the antenna and want to implement the lambda elements like resistor, capacitor, inductor, then you need to do proper biasing. Okay, you need to use proper biasing circuits. Okay, so here I am going to design some biasing circuits that we will follow in our each design. Okay, and here whenever you want to design reconfigurable, you need to keep these values in mind. Okay, or you can use these circuits. Okay, I mean, so for you have three cases. Okay, okay, we have a on we know in this case reconfigurable antenna, this is also a switchable antenna, so we use switches or pin diodes. Okay, so in simulation and in hard form, we in fabrication we use pin diodes. Okay, that is very helpful for us to design reconfigurable antennas. Okay, So in the case of the proper biasing, we need to follow these steps. Okay, we have a pin diode. Okay, we have a diode here. Okay, like this diode. Okay, so we will study the circuit diagram of this diode. Okay, because in CST you will not find, or in HFSS you will not find the pin diode directly. You need to assign or give some proper values. Okay, like a resistor, capacitor, inductor. Okay, so for the case of the if you want if you want your switch on, let us draw here. Okay, let's start with the okay, we have on when our circuit, pin diode working on condition. Okay, when it is off. Okay, so we will study and see its circuit diagram. Okay, that we will follow in CST software. Okay, so in the case of on state, when your pin diode is on, you need to follow this is your starting point. Okay, and you move from here, and you will have an inductor here. Okay, and you will have a resistor. Okay, in series. Okay, this is your inductor and this is your resistor. Okay, so you should keep in mind, in the case of on state, you need RL circuit. Okay, in series. Okay, okay, you need RL circuit in the case of on state. Okay, and in the case of the off state, you need RLC complete circuit. Okay, RLC circuit. Okay, okay, so in the case of the off state, you are starting from here, and you have an inductor here. Okay, and then this is in series. Okay, and then in parallel you will have a RC circuit. Okay, you have a capacitor or resistor here. Okay, this is same as on state. Okay, like this is your this is your LC or RL circuit. Okay, and in parallel you just add a capacitor here. Okay, okay, so this is your resistor. Okay, this is your inductor, and this is your capacitor. Okay, and what should be the values of these capacitor, inductor, and these things? Okay, let's start with the on state. Okay, in on state you need a inductor. Okay, and in series with a resistor. Okay, okay, we have a inductor here, and its value should be equal to 0.15 nanohenry. Okay, these values can be varied. Okay, but I prefer you if you take these values. Okay, and for the resistor you can take R is equal to 4.7 ohm. Okay, this is in the case of the on state. Okay, and then in the case of the off state, you have a RLC circuit. Okay, you have a inductor. Okay, and in parallel with the capacitor. Okay, okay, this is your inductor, and its value same as previous one. Okay, 0.15. Okay, 0.15 nanohenry. Okay, and for the resistor you have a value of 7000 ohm. Okay, or it can be 7k. Okay, ohm. Okay, and for the capacitor you have a value of C is equal to 0.017 picofarad. Okay, its units in picofarad. Okay, it's for the capacitor you have a units of picofarad, for the inductor you have units in nanohenry, and for the resistor you have in kilo ohm. Okay, 7 kilo ohm. Okay. just keep in mind these configuration. Okay, in the on state you have only RL circuit, okay, in series, okay, and in the case of the off state you have RLC circuit, okay, RLC circuit, and RC are in parallel, okay, RC are in parallel. And for the biasing condition, biasing conditions this is optional, okay. The first one is just keep in mind, okay. Here you can assign the voltage, okay, voltage, I mean plus point and negative point, okay, here ground, okay, and the same here, plus, this is your positive and this is your negative, okay. Okay, we start with the reconfigurable antenna, okay, and how we can connect diodes, and I have many ideas, okay, to share with you. And in CST there are many ways to implement this circuit, okay. I will show you some, and some maybe I cannot, because some other software may be used for this one, okay. Like let's start with this one.
Mr. Sarosh.
Yes, walaikum assalam.
For pin diode, this value is fixed.
As I told you, it is somewhat fixed, okay. Actually there are many types of pin diodes, okay. So but the pin diode I have in my lab that has these values, okay, so you can take these values.
Okay. And for MEMS diodes, we can use it?
Which one?
MEMS diodes.
Yes, if you know and if you have available in your lab, you can use. There are many types of diodes, okay, so it depends on you which one is available in your lab, okay. But this one is mostly available in most of the labs.
Yes, pin diode and MEMS diode.
Yes, MEMS switch you are talking about, okay.
Also, assalamu alaikum, brother Sarush. Also, some people I think using is a varactor.
Yes, some varactor diodes, yes. There are many types.
I don't use it before, but you have maybe idea how we can do it in the CCD, this varactor?
You need to check the circuit diagram of the varactor diode, okay, and then you can do in CST as same as we are going to do this one, okay. You need to check the circuit diagram, okay. We will look for it, and then you just need to implement.
I work in BIN, mostly I use the same number. A lot of people I think talking about this.
Wait a minute. Okay, so we have on state, okay. Now we start with the we start with the design process, okay. There I think 3 to 4 methods to design pin diodes in CST, okay. Let's check what we can do here, okay. So the same procedure of the antennas, okay. Substrate, we have a substrate here. I am going to use the FR4 substrate, okay, of size LS by 2, okay. Okay, we have a FR4 substrate here, okay. Now we can use ground plane. I use here partial ground plane, okay. I'm not using CPW, otherwise everybody will say I love CPW. Dear, what is his name? Kaiti, how are you? Are you here?
What do you think?
What is the question?
Hello.
Yes, dear Gulab.
Yes. What do you think? Yes. What do you think if we can use or use the SIW based reconfigurability?
Yes, actually in SIW based reconfigurable antenna it may be somewhat issue in using the pin diodes. Okay, what will be the issue? It may be issue of because in SIW, you integrate the shorting pins that connect your patch and the ground plane. Okay, and if you are connecting the pin diodes on the patch, on the radiator, on the SIW, then surely your every portion will be grounded. Okay, so in that case maybe pin diodes will not work very well. Okay, but you need to check it first. Okay, I am not sure, but I think that in SIW pin diode will not work very well. Okay, because all the shorting pins are connected with the ground pin, and when you use the I mean pin diode, the whole part of the pin diode will be grounded. Okay, and in that case pin diode will not work very well. Okay. Okay, here we design the ground plane. We will simulate and check. Okay, I'm taking values. Okay, this is my partial ground. Okay, and this is my, or we can use full ground when it is better. Okay, we can use full ground plane. One zero three four. Okay, this is our ground. Okay, now we design a patch, or in reconfigurable antenna you are more open than simple, I mean previous antennas. Okay, like patch antenna and other antennas. You can add pin diodes wherever you want, and you need to check if it is working well, then you can claim your antenna, okay, as a reconfigurable antenna. But if it not works very well, then you need to change the position of the only need to change the position of the diodes. Okay. Okay, here we have a field line. Okay, this is my field line. Okay, and for the reconfigurable you can create any shape. Okay, like yes.
I want to ask you. I want to ask you something about using the BIN diode or pin diode. You connect it to metallic bar. The gap between it has a fixed value. This gap, or we can do it as you want. Of course, it will become small, but has no standard value.
Yes, the gap should be 1 cross 1 millimeter square. Okay, 1 cross 1 millimeter square or less. Okay, for the we have here a strip line here. Okay, here like, and we have another strip line. Okay, you are asking about the gap where we will insert the pin diode. Okay,
yes.
You are asking about it. Okay, the gap should in the range, it should be in the range 0.2 to 0.5. Okay, millimeter. Okay, it should not be less than with this. Okay, 0.2, it should not be less than this one. Okay, because our sometimes fabrication machine cannot fabricate of gap less than this one. Okay, so you can take this one 0.2 to 0.5, or even you can take a size of, or, I mean for the diode, because you will use some small strips. Okay, and it should be of size 1 cross 1 millimeter square. Okay, and the gap it can be 0.2 to 0.5 millimeter. Okay. Okay, we design any shape. Okay, where we can insert the shorting pin. Okay. Okay, I start with this. I am taking any shape. Okay, this is a new shape. I save this file. Okay, maybe it gives some errors. Okay, we have a shape of the radiator, we have a field line, okay, we have a ground plane. Okay, now we how can we I mean make it reconfigurable antenna. Okay, let's simulate this one first, okay, and check what is the S11 value. Okay, and then we will add diode and we will check. Okay, today we will play in CST. Okay, or we can use discrete port to directly connect at 50 ohm. Okay, so for the discrete port you can choose the field line. Okay, to use discrete port. Okay, okay, you have a field line. Okay, you need to select the lower layer. Okay, now like this. Okay, okay, do not do like this because you will have wide discrete port, so it is better if you in the lower side you have a ground plane, so you will not have any issue. Or if you can use 2 points. Okay, like go to the modeling and choose the pick points, center, yes, this point, edge point. Okay, and click the lower edge. Okay, you will have 1 point. Okay, here in the point of the WCS. Okay, and then go to the ground and choose the this one, pick points. Okay, select this one. Okay, we have 2 points, you can see P1 and P2 point 2. Okay, you can use a discrete port. Okay, and 50 ohm already. Okay, click. Okay, now you have a 50 ohm.
Mr. Ahmed, sorry,
Yes.
man. I want to ask you for 15 ohm in this case.
Yes.
I didn't know check this normalized 15 ohms when I will start simulation.
What is your question?
I mean, in this case, when you use discrete ports.
Yes.
When I want to start simulation in setup solver, I check this 15 ohms normalized.
Here you are no need to do normalize because it is already 50 ohm. Okay, you did check that.
Okay.
We will simulate and check. Okay, because it is already 50 ohm. Whatever you write here, it will like if you write 75 ohm, then it will be of 75 ohm.
So we don't need to check the 15 ohms.
We can check after like after simulation we can check the reference impedance either it is 50 ohm, but I am sure that it is of 50 ohm. Okay, you don't need to do normalize. But in the case of the waveguide port, if you have any issue, then you can use normalize of 50 ohm. Okay,
Okay, thank you.
okay, let's talk with the until the simulation complete we will talk about its shape. Okay, okay, we have this shape. Okay, and how we can make it reconfigurable. Okay, we can try in many ways. Okay, like I have in my mind that I want to connect, and even this shape you see the edges, this edge, this edge, this one, and this one. Okay, so it may give you I mean circular polarized pattern. Okay, it can be of frequency reconfigurable, it can be of pattern reconfigurable, it can be of polarization reconfigurable. Okay, we will check after simulation. Okay. But how you can try and how you can make it reconfigurable. Okay, so you have like in my mind I have I want that I need another strip line here. Okay, micro strip line here. Okay, like this. Okay, like this. Okay, here I can use two diodes. Okay, at this point. Okay, I can use diode, and here I can also use diode, pin diode. Okay, so I will have two diodes. Okay, I will simulate and check what will happen if one diode is on, the other one is off. Okay, it is not necessary to use only one diode. Okay, you can use multi diodes. Okay, you need to check what will happen if one diode is on and the other one is off. Okay, and what will happen if both are on and both are off. Okay, because if we have two diodes we will have multi options. Okay, cases like one cases when both diodes are on. Okay, when the second is when the first one is on, the other one is off, and the first one is off, other one on, and then both are off. Okay, 0 0. So if it depends, these cases depend on the number of diodes. Okay, but I do not suggest you to use so many diodes, more than two. Okay, two or one are okay enough. Okay, so here we have option. I have in my mind that I can use this technique, or even I can make a slot here. Okay, horizontal slot here, and to disconnect this patch, and then I can use diode here. Okay, or maybe it can become a pattern reconfigurable or polarization configurable, because here you see here that if you have a current it will move like this. Okay, if there is no path to go on the other side, then maybe it will work as a linearly polarized. Okay, and suppose if the diode is on, then the current will come here, and then it will move in this direction. Okay, maybe it will become a circularly polarized pattern. Okay, so it depends. Okay, so if you want a pattern or frequency reconfigurable, then you need to select the shape of the antenna according to that. Okay. Or even I can try with other technique. Okay, so first select one shape in your mind, like I have selected that I have this shape in my mind. Okay, so I need to try multi times this shape. Okay, how can I make this shape reconfigurable? Okay, I have another technique in my mind that I can use a strip line here, another strip line here. Okay, and I can use diode here. Okay, at this point. Okay, so this is my another I have in this one in my mind. Okay, the other one, how maybe I can increase its length of the strip line. Okay, like this is strip line, and I create a slot here at this position. Okay, at this position I can create slot, and I can put my diode here. Okay, maybe because of this strip line it will become it will give me another frequency band. Okay, so you can check. Okay, also because you see there are three resonators inside, there are three poles inside. The first pole is this one, the second pole is this one, and the third pole is this one. Okay, maybe this antenna give me a tri band antenna. Okay, so if I have a three frequency bands, so it means I can vary the frequency bands, or I can make it a frequency reconfigurable. Okay, like I can use diodes at these points. Okay, at the lower starting points so maybe it will become a frequency reconfigurable antenna. Okay, so you need to think multi times of your design. Okay, you don't say that I have created the shape, I use the diode and it is not working. Okay, every design works, but you need to find the exact position of the diodes. Okay, did you understand what I mean?
Yeah, the other solution also you need to think about the direction of the diode itself.
Yes. Yes, maybe your diode would not work very well at this position. Maybe you will use at this position, or maybe use at any other position. Okay, so you need to
No, I mean the direction of the diode itself, the anode and the cathode.
You mean for example we have a plus point here and a negative point here of the diode, and you mean if we yes, but I don't think it will affect much more, but you can keep one. I mean, suppose I want in this in my mind, so I will only do with all diodes. Okay, I keep this position with all diodes. Okay, and even if it is not work, then I can.
The direction of the current will be effective.
Yes, we can check. Okay, we can check, but I prefer you it is if it is not working, then you can change, or maybe in polarization it will be more helpful. Polarization reconfigurable. So in reconfigurable, you need to create another folder, new folder, in which you will save all your data, and when you use diodes, so you can compare the results. Okay. And these are the results with one first simulation. Okay, you can I did not do optimization, like I can increase the length and width of this one. Okay, or okay, suppose if you want a desired frequency band, like some people design an antenna and it is working at 1 gigahertz. Okay, and they don't want this frequency, they want at 1.8 gigahertz frequency. Okay, so first you need to set your, I mean, you need to do optimization of this load as simple patch antenna you do in the previous lecture. Okay, and then you can use diodes, maybe once it is set at 1.8 gigahertz, and then try with the other use diodes. Okay, maybe it will when diode is on it works at 1.8, and when diode is off it works at 900 megahertz or more or less. Okay. Okay, so we save this result. Okay, I save this result. Okay, now I am thinking to add a pin diode. Okay, where I can add. Okay, so what I have in my mind, I have in my mind that I want to use another strip line at this point.
You can add a T shape. A T shape. Yeah. Or like the hammer. A
Yes.
hammer shape or something like.
Yes, it can be. Okay.
Nice.
Okay, so I can use, I am going to use diode my here. Okay. Okay, so here I am going to use my diode here. Okay, so as I told you, there are many ways to use I mean pin diode in CST to make a circuit of the in CST. What is the first method? Okay, one method is in this position in 3D. This is in 3D. Okay, and the second one is in schematic. Okay, so you can go to the schematic and you can use the you can go to the block selection tree. Okay, and you can use what you want, like circuit elements. Okay, you have a resistor, capacitor, ground. Okay, everything you what you need. Okay, you have a DC, you have a AC, you have a diode. Okay, and you have a even you can use this one. Okay. Okay, there are so many options. Okay, this one, okay, we have this one. Okay, antenna, and we have a diode here. Okay, some people do not like to use lumped elements like resistor, capacitor, inductor. Okay, so they think that what if they use IC. Okay, integrated circuits. Okay, so for the integrated circuits, you cannot use or I mean make any integrated IC in CST. Okay, so for that reason you need to go to the data sheet. Okay, and on the website you will find S2P files. Okay, the name as S2P files. Okay, you need to find. Okay, when you want to integrate the circuit, I mean IC on your design. Okay, so you need to find the S2P files on your data sheet. Okay, if you will find, then you can directly import in CST, and then you can do simulation. And okay, this is the first method. Okay, the second method is in the 3D method. Okay, in 3D you will have two methods. Okay, okay, and in schematic this is the third method. Okay, schematic. Okay, the first one in 3D, like you have a you can directly write, like I am going to use here. Okay, I have a lumped element here. Okay, this is lumped element mean what I want to integrate. Okay, like I want okay, for the on state. Okay, we know we need a resistor and inductor in series. Okay, so if I select this point, okay, you see I can select this point. Okay, select this one and select the other one. Okay, so you have a lumped port at this point. Okay, you can see here. Okay, now I have, you can see here, I have many options. I have a RLC circuit, I have a RLC, yes, RLC serial, in series circuit, RLC parallel circuit, RLC diode, and a general circuit. Okay, so we have many options here. In the general circuit, if you select the general circuit, what does it mean? Okay, you, if you click on this one, you will see, you can see three dots here. Okay, it means if you select this one, it will ask you to import the circuit. Okay, it means you have many options. Okay, you have spice files, you have all files. Okay, and you have many options here. Okay, what does it mean? Okay, let me explain here. Like you have ADS circuit, oh sorry, ADS software. Okay, you have ADS software, you have AWR software. Okay, and you have any other software that make these type of circuits. Okay, like resistor and capacitor. Okay, so in ADS, if we talk about the ADS, it like you make this pin diode in ADS. Okay, and you save the file of the ADS. Okay, and then you don't need to design any RLC circuit in CST. You just directly need to import the file from the ADS circuit in this case. Okay, and just click OK, and in this case you can directly use your lump element. Okay, your diode here. Okay, so this is the another method. Okay, you can use AWR.
Mr. Ahmed, in this case,
Yes,
how much the value of the pin it will be?
how much volume or
Value.
for the value?
Value. Yes.
You are asking about the elements, I mean for the inductor.
No, I mean when you have 3 pin, diode pin.
You are asking about the gap or value of the what you are.
I mean in this case, when you import S2P value of diode pin, how the value of the value must be?
For the volume, actually it is the when you go to the data sheet. Okay, you will find like you there are in data sheet you will find many options. Okay, like let me show you one here. Data
I can change the value of diode pin in CST or ADS.
No, you cannot modify the shape if you import any value. Okay, you cannot modify or edit the values of the lumped elements in if you import any circuit. Okay, file here. Okay, so
brother Sarouj, brother Tariq, you mean the value circuit, but brother Tariq, I think you will design the circuit as brother Sarouj maybe draw in PowerPoint, and you will include the files in it, and just you will import the file.
Yes, you can if you want, if you have
on case or off case.
Yes, in ADS you can create two files, one file for the on state. Okay, and the other file for the off state. Okay, and you need to import that file. If you don't want this one, then you can use other options. Okay, we have other options: RLC serial, RLC parallel. Okay, so for the on state I need RLC serial circuit. Okay, for the on state. Okay, so for the on state what I have, I need a resistor. What is the on state? Yeah, this is the on state. Okay, so I need a inductor and a resistor. Okay, so first I need a inductor of
I'm sorry for disturbing you, but I want to confirm what I said to brother Tariq. If I draw this circuit in AWR and biasing it as on case, yes, I can import it to the CST. It will work as on diode. Yes.
Yes.
Thank you.
Okay, thank you.
This I want to confirm.
Yes,
Okay.
you can, if you are used to expert in I mean ADS software, you can directly design this software sorry this on state in IDS and save the file as with the name on state. Okay, and for the off state you can create also this one in ADS and save the file like off state with the name off state. Okay, and like if you want to if you want your diode on, then you need to import the on state file. Okay,
It become easy. Easy.
yeah, yes it
Only
is, but you need to import multi times.
Yes, it's first time I know this because I get used. I will show you some if you give me chance at the end. I use the lambda element normally from here as you decided, but it will become amazing. So I can use it. I can use this model on and off model in any case easily. It's good idea actually.
Yes, it is good, but for the moment I do not have ADS, and for those who don't have installed ADS software, okay, so if they are only working in CST, then you.
I will try in AWR and I will share you.
Okay, so for the RLC serial, what we have, if we want on state, okay, we have only need inductor and resistor. Okay, okay, we only choose the value of the resistor. What is the value of the resistor is 4.7 ohm. Okay, I write here 4.7 ohm. Okay, and for the inductor I need a 0.15 nanohenry. Okay, here CST cannot understand your these values. Okay, like these units. Okay, nano, pico or other, it cannot understand. Okay, so you need to write the values. Okay, so we know the value of the nano is 10 raised to power minus 9. Okay, okay, so for inductor,
Or you can define the surcharge at the first in CST.
here you can see you can in CST you can write in this way. Okay,
I mean you can change the
yes, you can, yes, in CST you can edit the values. Yes, later on you can change. Okay, so we have inserted the value of the resistor and the inductor. We don't need capacitor, so are not going to write its value. Okay, so this is the RLC circuit, and we only choose RL circuit, and in they are in series. Okay, so I click OK, and okay, so this is the on state.
Please, can you return
Yes,
the lambda element?
yes.
Here for the type we have RLC series
RLC parallel.
and for the diode option.
For the diode option, it cannot work very well. Okay, because it in this option you cannot insert the value of the inductor. Okay, so I do not prefer to if you use this one. Okay.
Okay, thank you.
I asked before a person, he says the same. Thank you, brother. Okay.
Yes, because you see it does not enable the inductor option, so it is I do not suggest this option. But
I asked a person in Algeria. He said to me, if you want to use it, you can use a schematic.
Yes, that's why I just want to say that for the diode you can go to the schematic and you can use. We will learn in this session. Okay, so first try with the RL parallel series. Okay, so we have a resistor and we have an inductor. Okay, so click OK and let's simulate this one. Okay, so this is the state. This is the on state. Okay. What will happen with this one?
Okay, Mr. Ahmed, can you hear me?
Yes, I can hear you.
Uh, yes, yeah. It would be better for me. I'd like to know there is the actually SAW based reconfigurable leaky wave antenna. Uh, what are the benefits of the integrating the leaky wave antenna as well as the SAW for the reconfigurable behavior?
Uh,
If you know about it.
yes, you can do work on it, okay, but be make sure about the, I mean, SIW technique, okay, because if it's suppose, okay, let me explain in here. Okay, this is your antenna, okay, this is your, I mean, substrate, okay, and you have a patch, okay, like a small patch, not a big patch, okay, like you have a small patch here, okay, and you want and this is a patch, and this is the like this is your, let me draw with this is your ground plane, okay, on the other side, okay, because in SIW the patch is mostly the image of the ground, okay, I mean the ground is mostly the image of the patch, okay, so you are using the shorting pins, okay, to connect this, okay, you are using the shorting pins, okay, here to connect the patch and the ground plane, okay, and you know in diodes, in diode case, you will also use the, I mean, shorting pin to connect the to provide the ground plane, okay, so for that reason maybe it will not I mean the pin diodes at this point area will not work very well, but in the case outside at this position, or maybe you will add another patch, okay, to connect with this one, okay, like this is your patch, okay, this is your another patch but a part of the radiator, okay, so you are connecting this with the SIW, and you can use diode in this case, okay, but here you will see all this patch is grounded, okay, because of the shorting pin connected with the ground plane, so that's why, that is what I am saying, that maybe pin diode may not work very well, but I did not simulate and check whether it is true or not.
Okay.
I don't know why it is not working, okay.
Mr. Sawaj, try to put one backbone instead of
Yes,
this
I
critical.
am thinking. Why, I don't know why it is giving error, but even if it did not give me any error before. Okay, let's leave this one, this file, create another one, and I will copy this file into another one.
This problem of the meshes, I think.
I am copying this file, okay, and I'm pasting here. Okay, it is better if I create a new one, because the boundary, you can see here, this is the problem, I think. In this case the boundary box is very near.
Oh, I think the boundary is changed. You
Yes,
can see it's all electric, and must be open.
yes, I don't know how it is changed. I did not change it.
Is actually it's do with me sometimes.
Okay, let's try with this one.
And Mr. Ahmed, check the boundaries before to the condition.
Yes, it is okay now, but in that case your boundary is very near to the. Okay, let's assign the port, then we will check here. Yes, this is okay. Okay, yeah, I create a simple shape here. Okay, so that we only our main target to learn working of the pin diodes. Okay, so I am just making a simple shape. Okay, okay, now we create here another strip line. Okay, okay, let's add diode here. Okay, the other thing, you can choose the pick points. Okay, you can pick points. Okay, and then better to add lumped port. Okay, otherwise it may give any other error. Okay, for the resistor we have 4.7. Okay, for the inductor we have 0.15 nanohenry. Okay, till then we can start work, we can learn the process in the schematic. Okay, so I am removing my lumped element here. For this is for the on body, I mean sorry, on state. Okay, in the case, I mean, you can add R and inductor. Okay, resistor and inductor in this case. Okay, in series. But if you want in parallel, you can use use two ways. Okay, like if you click on the RLC, it means all are in parallel. Okay, it means like this. Okay, if you click on the RLC serial in CST, it means all are in series. Okay, like in the resistor. Okay, inductor and capacitor are all are in series. Okay, if you put the value of 0 of capacitor, then it will not consider capacitor. Okay, it means only R and L. Okay, so but in the case of the RLC serial, I mean parallel, it means all are in parallel case. Okay, like you have inductor. Okay, you have a resistor. Okay, you have a capacitor. Okay, so in that case it means all are in parallel. Okay, but we don't need all are in parallel. Okay, we need if we see the off state, we need R and C. Okay, R and C, we don't need inductor, okay, in parallel case. Okay, we need resistor and capacitor in parallel and inductor in series. Okay, so what we will do, we need two circuits. Okay, here we need here we will use RLC serial. Okay, first. Okay, like we have a resistor, we have inductor, we have a capacitor. Okay, okay, and then we need RLC parallel circuit. Okay, parallel circuit. Okay, okay, that is, this is this one. Okay, so in RLC series we will remove resistor and capacitor. Okay, and it will work only inductor part. Okay, and then we will use the RLC parallel, in which we only need like this is connected with inductor and in parallel with the capacitor. Okay, and resistor. Okay, okay, so in that case we don't need inductor. Okay, so we only need a capacitor and resistor. Okay, so did you understand what I mean? If you want to use RLC parallel, then you need to use if you want to use the off state, then you need to use RLC series and RLC parallel. Okay, so in RLC series you will neglect resistor and capacitor, because you only need a you only need inductor. Okay, and then in parallel you need inductor and a capacitor and a resistor. Okay, so that's why here you will do, you need two strip lines here. Okay, you will remove this one first. Okay, like this. Okay, and here you will create another one. Okay, another strip line, very small thickness. Okay, like let's know the size of this gap. Okay, this is 0.5. Okay, and I need to shift my WCS at the center. Okay, 0.25. Okay, this is at the center. Okay, so I need another, what is the width of this gap? Is 2 millimeter. Okay, minus 1 on this side and 1 on this side. Okay, and for dV you can take 0.1 here and minus 0.1 here. Okay, just to pick the points, or maybe it can be more less. Okay, 0.05. okay, like this, and do minus TP. Okay, minus TP. Okay, now you can add two lumped elements here. Okay, in the case of the off state. Okay, so you use the lumped elements. Okay, or you can assign pick points or okay, lumped elements. Okay, first what you need, you select this one and this one. First select this RLC circuit. In RLC circuit you need only in the on state off state, what is the off state? Yes, this one. You need inductor. Okay, of 0.15 nanohenry. You need only inductor 0.15 nanohenry. Okay, sorry, e to the power minus 9. Okay, so click OK. Okay, so this is your inductor, only inductor. Okay, and then you need a parallel. In parallel, what do you need? You need a resistor and a capacitor. Okay, so you need select the RLC parallel. Okay, and you need a capacitor of 7000. Okay, 7000, and the capacitor of 0.017. Okay, picofarad capacitor, 0.017 pico, e minus 12. Okay, okay, now this is, you can see here you have two diodes here. One is the inductor and the second one is the RC circuit. Okay, in parallel. So this one complete make a one diode. Okay, these two will work as a one diode. Okay, so did you understand? For the off state, what do you need to do? For the on state,
Excuse me, Mr. Sarosh, I want to ask about the insertions of the metal bar between the gap. Sometimes the effective this insertion of the metal bar may be effective to increase the resistance and the capacitor effect. What can this problem to solve it?
you are talking about the biasing conditions.
I want to no. I ask about when the insertion the bar, the metal bar or the slot. This maybe increase some capacitive because add the capacitive of the system and also add the resistance of the system. So how to calculate this to remove it or to consider that?
Do you have any any work on it or reference paper or what you are asking about? Okay, if you have any.
No. Actually, I didn't have any work about this direction, but I want to ask about that because you have this is insertion a new alarm element, like a new alarm element when they put parallel bar between two transmission lines. Yes, like this. We put a new capacitive, a new add value of capacitive, and also add a new resistance.
Okay, let me explain a little bit about it. Okay, so this is your diode. Okay, I mean this one completely will make a diode. Okay, like if you in diode you will have RLC circuit. Okay, and if it is working only RL in series, then it will behave as a on state. Okay, combinedly it will work as a like this one. Okay, you have a diode here. Okay, like IC, I mean IC circuit. Okay, so if you are talking about the problem that you have, okay, for biasing, I mean for biasing conditions, you need to add the another, I mean sorry, you need to add any additional resistor or inductor or a capacitor. Okay, to control this problem. Okay, for biasing conditions, like you have a pin diode here. Okay, okay, like you have a pin diode here. Okay, and you need to add you can try with one. Okay, if you add inductor in series, okay, and a resistor. Okay, I mean RL circuit. Okay, try again, and then you need a ground plane. Okay, here, and then you can I mean this one, only this point, sorry. No, in diode. Okay, in diode, when you face any kind of problem, then you, for biasing conditions, you can add another inductor and a resistor in series. Okay, and it can be up to 50 ohm. Okay, 50 ohm or maybe less. Okay, and for this one you need to use a high value of inductor. Okay, like it can be in range of, I think, 60 to 70 nanohenry. Okay, you can try this one. Okay, this is your positive and negative.
Thank you, Mr. Sarosh.
Okay, did you understand or not?
I just about F2. I think about the transmission line because the transmission line between if separated between them or make a gap between the two transmission line, you put a capacitive effect. So to remove the capacitive effect, you put the inductive effect. So now I understand here to recovery about to cancel the capacitive effect, right?
Yes, and DC, for the case of the DC, capacitor will blocked. Okay, because in the DC it is blocking capacitor. Okay, and for the inductor, DC can pass and AC can flow, okay, in this case. So that's why if you use a, in this case you cannot use a capacitor, okay, that's why we are not using capacitor. You can use RL circuit to control this problem, okay.
This is the reason you use the inductive effect to cancel the capacitive effect
Mhm.
between two transmission lines.
Yes,
That's right.
yes.
Okay, thank you very much.
Okay, did you understand the on state and off state of this reconfigurable antenna? This is the on state, okay. You can as I told you, for the you can use the RLC serial, okay, in that case, okay. Okay, if you want to but I prefer you if you use schematic, okay, that is more accurate than the previous one, okay. I mean for this one, okay, this is more accurate way. Okay, so how to use schematic, okay, you if you zoom this one, you will see you have a this is your antenna, okay. This is your antenna, okay. So how can we use schematic? This is very simple and very easy, and you can easily do in this way, okay. Like for this one, okay. Okay, so let me remove the lumped elements. Where are the lumped elements? Okay, this is I remove the lumped elements, okay. So for the, in order to use the schematic, you need to use multi ports, okay. You cannot use schematic with a single port, okay. You need to use multi ports, okay, like maybe 2 ports, maybe 3, or it depends, okay, like, okay. So for the case of the on state, okay, or on state whatever maybe, you don't need to shift the RLC serial or parallel, okay. You just need to use two another ports, okay, like we have one port here, okay, this is one port, okay. And if you go to the schematic, you will also have one port here, okay. This is your one port, okay. And we need another 2 ports, okay. We use another 2 ports, okay. uh, okay, we can use this one, okay, because we have a strip line in the center, okay. You need to use a small strip line, this one, I am talking about this one, okay, to connect 2 ports, okay. So first port, you need to use the, I think, discrete port. Okay, so you need to use 2 ports here. Wait a minute. Yes, you can even use this diode, okay. But let me check whether it shows any or not. Okay, it will not show you any, okay. So we need to use the discrete port, okay. Okay, let's do with this discrete port. We have a discrete port, okay, this one, okay. We are selecting this one and this one, okay, here. This is our port 2, okay. Yes, we are selecting, okay. Okay, now we need another port.
Somebody use a board. I think we can remove this strip metallic because we will make a circuit there on the other side, or we need to use it.
Okay, we have a 2 port here, okay. And if you go to the schematic, you will find two more options here, okay. Second port and third port, okay. And now in this case, it means for the first port, you need you see there is a waveguide port. This, for the first port, this is your first port, okay. And there is a waveguide port. This is your waveguide port, this one, okay. So you need to use the external port here, okay, of 50 ohm, okay. This is of 50 ohm, okay. Double click on it, okay, and then you can connect easily. Okay, so this is your external port, main port, okay. I mean this one, okay. For the other 2 ports, we don't need a discrete I mean waveguide port, okay. We need lumped elements for this one, okay. And you see I mean for this one case, you need there are 2 ports, 2 port, second port and third port, okay. And you need to use the lumped elements in this case, okay. Or I think maybe what I mean, Muhammad, you told me to remove this strip line, okay. This one.
Yes, we do. No, we don't need to use it.
Yes, I think so, because it is maybe issue, okay. So we can delete this port, okay. We again use this port, okay. So So in that case, I think we need to use here we can use second port here and third port here. Oh, I mean pick points and use second port here. Okay, in this mean I think so, in this way, and the third port here.
Yes, they will give you a point.
Yes.
Like 2 and 2 prime, something like this. 3
Yes.
and 3 prime.
Yes, and now we have two second port and third port, and go to the schematic and we have the same second port and third port. Okay, and we can connect here. Okay, like we can make our RLC circuit here. Okay, like on state and off state. Okay, for the on state, what we need, for the on state we need a resistor and a capacitor, resistor and a inductor. Okay, so we can draw here. Okay, I mean choose here. So if we click on the lumped circuit elements, you know, in the down bar you can see navigation tree and the block selection tree. Okay, so you need to go to the block selection tree and you need to select the expand this one. Okay, so you need a resistor, okay, and you need a inductor. Okay, this is, yes, you need a resistor and yes, inductor, yes, and also you need a ground. Okay, okay, now we zoom out. Okay, okay, so for the case of the, I mean for the case of the on state, we need parallel, I mean sorry, in series R and L circuit. Okay, so first we need okay, we have a resistor. Okay, okay, we connect, you can use this connector. You can see here, this is a connector. Okay, and sorry, wait a minute, let me check where is the port 2. This is port 2. Okay, and this is port 3. We are moving in the upward direction. Okay, we are connecting, I mean at the third port we have a positive, and the second port we have a negative. Okay, so in that case maybe I mean sorry, in the schematic we have a second port, this one, and this port. Okay, and if we see this one, we need, it means we have at positive point we have a third port. Okay, and at the negative point we have a second port. Okay, so in that case for the third port we need inductor. Okay, so in this case we need inductor here and resistor here. Okay, okay, so we click on the connector. Okay, and we connect this one, this circuit. Okay, okay, we have inductor and a resistor. Okay, and then at the second port we can connect the ground. Okay, okay, and at the first port we need another, I mean where is the VCC, yes, you can even rotate this one. Okay, you can rotate left, you can rotate right. Okay, so this is our positive point. Okay, this is our positive point. Okay, and this is our negative point. So we are, or even you can connect with this ground. Okay, if you want, or even you can common ground plane. Okay,
Actually, brother Sarusha, I use also another way, but because it was 2 years ago, but I need to return to my own work, because I was I make in one port I make two ports, 2 and 2 prime, 3 and 3 prime, and I separate it from each other. It also work.
Okay, it will also work. Okay, so you can also try this one. Okay, okay, so
I'm sorry. Yeah, I remember because I use two diodes using one. Yes, I'm sorry.
Okay, so yes, what is the value of the inductor? We have 0.15 nanohenry. Okay, so in this you click on the inductor and you can write the value here. Okay,
this is very nice. This way is very nice.
Yes, this is much better than the previous one. Okay, so what is the value? 0.15. Okay, 0.15, okay, nanohenry. You can select the units here, okay. Okay, we have an inductor, and for the resistor what we need 4.7, okay. So you can select 4.7, okay, and make sure about the units, okay. This is in
on state.
yes, this is on state.
Yes, on state, yeah. Right, Sarush, I want to ask you about this schematic diagram because I tried before. If I remove this port and I put some lambda element, okay?
You are talking about this port?
Yes, if I remove it, I want to ask you because you're coming to the schematic. If I remove it and I put some lambda element, I arrange it by some way and I tune it, and I run the simulation and I put the same simulation as 3D for the S parameter. This means this lambda element is matched with the antenna. So this means this consider also the antenna equivalent circuit. It's correct or not?
You cannot simulate antenna without this port, okay. Like if you remove this one, even if you connect this one with this one, you cannot simulate this one, okay. If I click on this,
I know. I will put the port and this port because it's 50 ohm, okay.
Yes.
And I make a circuit. If I make a circuit, this circuit, you know, from the maximum power transfer to transfer the power from the port to the load. Load is considered like antenna. You understand what I mean? Our load is antenna. From that, this circuit is similar to the antenna. For that, the power totally or the maximum power is transferred. Is correct this concept or not?
I think so. I think yes. I think acceptable, but I'm not sure.
I tried before and I got some results. Because you know, if the power is transferring from the board to the load by the maximum power, this means this transmission which I made is equivalent to the circuit of, or can be represent the equivalent circuit of the antenna, because antenna considered like a load in our case.
Yes, right. Okay, for the
I'm sorry, because
no worry.
Because I did think a circuit maybe some years.
No worry. Okay. Now how to simulate this one? Okay. The schematic and the 3D. Okay. So first you need to go. You need to run the simulation for this schematic. I mean, for this 3D. I mean, you start the simulation. Okay. Here it will not start because of the boundary problem. Okay, so you can simulate this one first, okay, and don't worry about these ports, okay, that you are using 3 ports and it will results will change. Now results will not change, and you know we are using 3 ports, and surely it will give you many S parameters like S13, S31, okay, others, and we only need S11, okay, in this case. So you are checking only for the S11, okay. So when you simulate this one, and it will give you only you need to only check with the S11, okay. And once the simulation will complete, then you need to go to the schematic, and then you will again simulate this circuit, okay. When you click on the simulate update, okay, and it will start the simulation, okay, and it will ask you what parameter you need to calculate, okay. You need S parameters, okay. So you click on this one and click OK.
Yes.
And then it will ask you for the samples, okay. So here if you want to if you are exporting, I will also explain this one, okay, but here we are using the CST, okay. So you can take this one, okay. Okay, and you need to create S parameter results, okay, and in S parameter, okay, you need to click apply, okay, and it will start simulation, okay. Here we will get the and it will not take much time, okay. This is giving error because of the problem in the 3D, okay, because of the boundary condition, okay. But it will not in the schematic, it will not take much time in simulation. It will take maybe 10 second or 5 second, okay. So in this case you can use the use or simulate your design, okay. Reconfigurable antenna, okay. This is this is your on state, okay, and for the off state you surely need what you need inductor and R and capacitor in parallel, okay. So you need to remove which one is, yes, this one, okay. You need a resistor and a capacitor, okay. So you connect a resistor, where is the resistor, and a capacitor, okay. So you can connect them in parallel, okay. You need to do this one, okay. Okay, in this case you can even change the value of the capacitor. Okay, what is the value of the capacitor is 0.017 picofarad. Okay, so units are in picofarad. And for the what happened, okay, for the resistor you need a 47 or 50 ohm. Okay, oh sorry, 7000. Okay, so you need, even you can write 7000 ohm, or even if you can write 7, but you can select the units kilo ohm. Okay, so in this case like this. Okay, and you can simulate this circuit. Okay, this is your reconfigurable. In this way you can simulate your reconfigurable antenna. Okay, and for the other elements, like I let me explain a little bit about this one. You have this one strip line. Okay, here let me check. Where is the option? Yes, this one. Okay, let me first explain this one. Once you complete your simulation in the schematic, okay, then you will find your S parameters here. Okay, you need to go to the navigation tree. Okay, then click on the task. Okay, and then you can select the click on the S parameter, and it will ask you for the S11, S21, S. Okay, and then you can select the S11. Okay, and then you can go to the post processing and can export your results. Okay, and for the from the data sheet, like if you even don't want this one, even if you don't want to use these lumped elements, okay, like resistor, inductor, capacitor, and you want, I only want to use the data sheet, or I want to use the files, or like data sheet. Okay, so you can even delete all this one. Okay, like you can delete this one, and in that case you can directly you don't need to draw, I mean need any capacitor. I mean if you want to, if you are exporting the data from the data sheet, you don't need any resistor, inductor, capacitor. Okay, you directly import the data. How you can import I mean in the data sheet, you need to download the S2P files. Okay, but I did not check S2P files of the reconfigurable antenna, of the pin diode. Okay, I will check if there is available. I will download and send you. Okay, and for the other data sheet I will show you. Okay, here I have a data sheet of another pin diode, not a, I think pin diode, but is the amplifier. Okay, but it works same as which one. Okay, so you to import the data sheet, I mean the S2P files, you need to go to the data import. Okay, click on the data import, and you can select the test on file. Okay, if you click on the test on file, you need to drag this one and paste here. Okay, okay, it will ask you to import the S2P files. Okay, and you need to you can click on this one. Okay, and then you can find where you have saved the files. Okay, like I have saved in, okay, so this is sorry, no, this one. Okay, this is the data sheet. Okay, that I have downloaded from the internet. Okay, and when you open this folder, you will have many options. Okay, it will ask you like this pin diode is available with this current and this voltage. Okay, so you can click on this one, and in this way it will import the data sheet is imported in your CST schematic. Okay, and then you just need to connect the ports. Okay, I mean you have two option uh, okay, you need to connect this one only, no need to design the resistor, inductor, or capacitor. Okay, in this way you can connect, and even
to download this file.
yes, I will check if there is available on the pin diode website. Okay, and I will send you. Okay, and in this way you just need to connect this one. Okay, and it will yes, just need to connect this one. Maybe for the on state you will have, and you need to import the file, okay. Or even you can draw I mean you can save the files in ADS. If you design the on state and off state in ADS, just save them for lifetime, okay. And just you need to import the files, okay. And you just you can import in this way, and you can just directly run the simulation, okay. So did you yes.
So from which websites we have to download this S2P file for the pin diode and the varactor diode?
The main website, I will check and download, and I will send you by email, okay.
Okay, sir.
Yes, I need to find it, okay, because some on sub website it is available, and on some it is not available data sheet. The file you download will be in a zip file, okay. Will be a zip file. On the website you will find it, I hope so. You should find it. Maybe like this. Yes. Like this, okay. You will find a zip file, okay, and when you open you will find many files, okay, like for the on state and for the off state, okay. In this way you can also find for the pin diode, okay. So you just need S2P files, okay, keep in mind S2P files.
Sir, so in S2P file we have to give any external DC bias voltage or not?
For the actually you need to download two things, okay. You need to download the S2P file, and you need to download the data sheet, okay. When you download and open the data sheet, they will explain how you can I mean use the, I mean if you need any additional resistor or capacitor, okay. They have explained everything in this PDF file, okay.
Okay, sir.
So did you understand the way? There are many ways, okay. Also I did not have installed ADS software, otherwise I could show you how to import, but here I don't have, okay. So even you can one more interesting option, there is another option, the third one, the first one is this one, 3D, the second one is the schematic, okay, and the third one is I think here, yes, assembly, okay, like this. Okay, so there are many tasks for this, like how to create or stubs, okay, like if you go to the block selection, okay, and you need a micro strip, okay, let me remove this one for a while. Okay, I want okay, port 3 and port 4, okay, I need a stub here, okay, with 2 port, yes, this is this one, okay, you need to keep this one very far, and this one use, okay, connect this one. Okay, like if I mean if you don't want any stub here, okay, and then you can easily create this one, okay, with this one, okay. Even you can draw your design, I mean your antenna, with this assembly, in assembly, okay, with these stubs, okay, like you have a bend, microstrip bend stubs, okay, many other things, okay. So you can even design your antenna in this way, okay. You need no, you cannot design even if you don't want interested to design in this 3D, you can go to the schematic and use and draw your antenna here, okay. This is somewhat different with the 3D, okay, like even for the substrate, like you want to use the substrate, okay, you can click on the like this one, okay, like I am using this stub, okay, I have a stub and I have a gap and with the strip lines, okay, and surely this I mean this is a complete stub, okay, with like with ground, substrate and strip lines, okay, micro strips, okay. So if like suppose like yellow one is the copper, okay, the red one is the substrate, okay, and the substrate, and there is a ground plane on the back side of this substrate, okay. And how can we I mean how can we assign the dimensions and properties and materials of this substrate? So you need to select this one, you will find this one, okay. You no need to, when you even import this one, you don't need to assign the values again, okay. This is common for everyone, okay, like if you are importing the red colors stubs and the folders or whatever it is, you need only one time, okay. So you click, when you click on this, you will find many options here, okay, you can find here, okay. So you can you are using fr for substrate, you can write the epsilon value of the fr for substrate, okay. And what is the dimension of the fr for substrate, okay, like if you are using, if you want to use here mostly stubs are of 1 cross 1 millimeter square, okay, but if you want of more size, you can increase or decrease the size, okay, like 2 cross 2 or more, okay, whatever you want, okay, it depends up to you, okay. So this is like this is the same as we write in the 3D, you know, this one like when you select this brick, and you will find many options, u minimum, u maximum, y minimum, y maximum. This is same as in this schematic, okay, like this is minimum, x maximum, okay, y minimum and y maximum, okay, 3 cross 3, okay. And you can assign the thickness of this substrate, okay. What is the thickness of this substrate? It is 1.6 millimeter, okay. And you can write 1.6 millimeter, okay. Where is the thickness? Yes, and you need units in millimeter, okay. Just check, yes. And you need to, you need all units are in millimeter, so you need to change the units, okay. Okay, after this what you need to do, go down, okay. Now you have assigned the properties of the substrate, fr for substrate, to this one, okay, this stub. And then when you click on the assembly, okay, you will find sorry, it will not show you. It is not, yes, this one. This I put the dimensions in other way. Okay, so this is your stub, okay, that you have designed. Okay, this one. So in assembly, when you can connect your antenna, okay, like you can use many ways. Okay, so you can use what you want, like you need a circular patch antenna, you need sorry, rectangular or circular. Okay, like if you need a circular patch antenna, click this one. Okay, so and then you can connect more one, like if you need a bending at this point, okay, you can bend your antenna. Okay, and in this way you can use many boxes. Okay, and when go to this schematic, you will find many you will see your design, whatever you are designing. Okay, but it is very time consuming.
Excuse me, Mr. Sarush, about the strip line. This is it's perpendicular to the antenna. Is there any configurations for the parallel? It must parallel to the antenna.
You are talking about this one?
Yes.
No, no, actually, I have wrongly written the dimension in this case. Okay, so you need to change your dimensions according to the substrate. Okay, so that it will be aligned with your substrate. Okay, not parallel. Okay, I mistakenly choose another dimensions. Okay, like you need to check again and again. Like if you select this one, you need to vary the values. Like you can use 1 2 cross 2. Okay, then you will see in the schematic your size will change. Okay, or if you want in horizontal, you need to change the values. Okay, according to that schematic. Yes, so it is very time consuming. I did not use this one before, but I am just showing you to working of these things. Okay, there are many ways to design, but this is very time consuming. Okay, so I do not mostly use this one.
ADS, they do the same way.
Yes, the same as in ADS.
What brand solution you said about what spice model? You said you will talk about us about it.
About what?
Spice model.
Yes,
model.
yes. Actually, the spice model and the this one touchstone file are the same. Okay, you the working principle of both are same. Okay, you also need in spice you also need to import. Maybe check. Let me check here. You will find us.
I need to export the spice model, but what it mean? Spice model for the antenna?
No. This is the name of the file. Like you have a for the S2P file. Like there is no name.
I know.
Yes.
I know this spice. My mind is go to another direction. I guess we can import all this schematic diagram into spice because I know it can be opened by the spice, which we get used for electronics.
Yes, for the electronics, like you cannot even directly import the ADS file in this schematic option. Okay, so you need to export as a spice file from ADS, and then you can able to import in this schematic.
I got it. Thank you.
Okay.
Also, Mr. Ahmed, how to make the strip line behavior as the pin diode?
No, this is not working as a pin diode. I am just showing you that if you if you want to use here, if you want this one, what is does it mean, strip line whatever, you can just select this one and you can create this one. Okay, like if you it is not necessary. Okay, this is not working as a pin diode. Okay, I am just showing you.
Okay.
I am just showing you to go. If you can also there is an option in the assembly option, like okay, like this one.
Okay, thank you.
Sir, if possible.
Okay.
Yes, Kaiti.
Sir, if possible, you share the SP2 file or a touchstone file, otherwise ADS file for the pin diode. For example, bar 6402 or 03. So that we have to simulate in and see the output of that.
Yes, I try, and I will try to install ADS software. Okay, or if you already have installed the CST file, I mean ADS software, then you can even design in ADS. Okay, if you don't have ADS, then you can even directly go to the circuit elements and you can design what you want. Okay, but if you need any special component, okay, any pin, a special diode, so you can use the this one. Okay, data import. Okay, you can use touchstone file. Okay, or spice file. Okay, here this is a spice file. Okay.
In a net, there are numbers of files available. For example, different pin diodes and the varactor diodes. In that file, there are the spice models, that is the cadence models. Number of models are available. So which model we have to use for this spice or the touchstone model?
For the touchstone, yes, you can use this touchstone file. Okay, this is which one, where is this? Yes, this spice file. Okay, you see here, you will only find the spice or circuit, okay, that you made in ADS, AWR, or other softwares. Okay, this is directly import your circuit. Okay, but for the touchstone, it will give you you see, you will find a block here. Okay, and you can select this one. Okay, it will give you a block like this. Okay, and this block will work as your pin diode. Okay, like if you import the pin diode from the data sheet. Okay.
So that touchstone is a simply on version of the pin diode.
Suppose this is your IC. Okay, and everything is integrated inside it. Okay, when you import the from the data sheet. Okay.
Okay.
So what is your question, Tariq?
Mr. Ahmed, for this way or this method is for reconfigurable frequency and parent, and the third option, what is it?
Actually, here I just explained the schematic to
polarization.
yes, I use this method schematic just to show you the how to use the pin diodes. Okay, but in the case of the in the case of the other reconfigurable, like if you want to circular, pattern reconfigurable, so then you need to use the you need to change, or you need to yes, you need to change the direction, or sorry, direction of this pin diode. Okay, like if you will not use here, you can use here. Even when you are simulating your design, you need to check all the three things. Okay, at the same time, like you need to check the frequency, you need to check whether there is any change in the frequency with this diode or not. Okay, also you will check whether there is any change in the pattern or not. Okay, and also you need to check whether there is a change in the circular polarization or linear polarization or not. Okay, so you need to check. If you achieve any of them, you can claim that this antenna is works for the pattern reconfigurable antenna. Okay.
And what is the limit of the number of the diode?
There is no limit. Okay, but try to use as less as possible. Okay.
I just you, Tariq, I think maybe 2 or 3 years ago when I started working, there is a paper in AUE. Yes, I think they're putting almost about 5 there.
Yes, you can use up to 10 or maybe, but as I suggest you, because in research they are reducing the number of diodes. Okay, if you use many diodes, how you can claim that I have achieved this one with less diodes. Okay.
But Sarosh, this paper, this paper was with me, and I will send it to all, inshallah. But this paper is very, very simple paper. He making just a strip and increasing the size of the strip, and he catching many matching frequency.
Okay, now I want to share some ideas related to reconfigurable antennas. Okay, and every design I like to share. Like, let me show you one of my design reconfigurable antenna, just to show you some ideas. Okay, this is the design. I'm working on it. Either I can open it or not. What happened this one? Okay, let me delete this one. this is my design that I am working on it, but I am still working. I did not find time to work on it. Okay, so you can see I am trying to achieve all these three things. Okay, like as I told you, the three things what we need: frequency, pattern, and polarization. Okay, so here I think I have one paper that has achieved all the three things. Okay, where is the paper? Hmm, I forgot where I pasted the paper. Sometimes I yes, there is one paper. That has published in IEEE AWPL, not mine, but I am following that papers, and they have achieved all these three things. Okay, they have achieved all these three.
I check both. I will show you my paper if you give me a chance. I check both the frequency and also the pattern. Pattern it was fixed, but the frequency changed.
In that paper, they have achieved all these three things. Okay, they have achieved the frequency reconfigurable, pattern reconfigurable, and polarization reconfigurable. That was the amazing design. And also I am trying to achieve the same. Okay, you can see here this is my design. Okay, I am working on it. I will use diodes here. I am using 4 diodes or maybe 2 diodes. Okay, at first I used 4 diodes, but now I am working on with the two diodes. Okay, I will use 1 diode here and 2 diode here, I second diode here. I have given this talk to my one of my student. Okay, because I did not find time to work on it, and also I am using this circular. Okay, to and I will use another diode here maybe to achieve the circular polarization behavior. Okay, so
Is
you
red color? Is red color is
yes for the diode, or yes, in simulation you can also use this diode, I mean this one as a diode. Okay, but this is not recommendable. Okay,
It is a strip, metallic strip.
yes, metallic strip, but it
So
was
some people do it, Brother Sarosh, even in not in simulation, they do it also in fabrication because they have no facility.
yes.
To make a
I have seen even my friends even use this pin, I mean this simple strip. This is of copper. Okay, of size 1 cross 1. Okay, you can even use, if even you are not able to achieve results, you can use 1 cross 1 millimeter square short strip. Okay, to work like if like suppose if you want on state, you need to what you need to do. Okay, just connect it for on state. Okay, and for the off state just remove it. Okay,
Yes.
where is the design?
Brother Sarosh, if you have a time, shall I show you my iWatt design? It's already published in 2020.
Okay, we will see in the maybe you can send me on WhatsApp because at this moment I have some other works. Okay, so for the I mean to disconnect, when you disconnect it will work as off state. Okay, when you connect this one it will work as a on state. Okay, this is very simple method. Okay, but this is not recommendable. Okay, because if you are going to publish a journal, then the reviewers will ask you proper biasing and proper lumped elements. They will ask you to use lumped elements. Okay,
It is a very big matter.
yes.
But Brother Sarosh, I want to ask you, sir, those people who are using the pin diode or varactor, when they measuring in the real, I think when they're putting the test chamber, I think they must adjust the biasing. It will not affect in the radiation pattern itself. You know, simulation is not a big matter.
Yes, right.
This biasing equipment.
Yes, right. Wait a minute. There is a question of Flip. Yes, Mr. Flip.
Yes, Mr. Saroj, on achieving all the reconfigurable actions with one antenna, the polarization, the pattern, and the frequency. I don't know how is there an effect, because I read on something that it states the characteristics linkage effect, where when you are varying one property, maybe you are changing the frequency, you are reconfiguring the frequency, it will have an effect on either the polarization or the pattern. So therefore, you will not achieve the mutually exclusive reconfigurability you want for your antenna, because once you are changing the frequency, the polarization and pattern may also be changing. How do we resolve that?
Yes, right. I don't have any paper. I mean, for the that has achieved all these three things. Okay, they have actually used very like I have a design like this. Okay, I have seen in that paper how they have achieved. Let me share this a little bit. I did work with your supervisor on this same reconfigurable antenna. They have submitted the paper. What about the paper?
Yes. We are currently working on resubmitting to a different journal, so she will contact you actually.
Okay, so in that paper, I have seen that I will again look search for that paper and will send you. Okay, and in that paper, suppose in this case, if you want to implement your like you have a diode here, okay, and in that case they did not use diode like this. Okay, here we are using like this, but in that case, in that paper, they have not used diode like this. How they have used diode? They have used in this like this. Let me explain here. Suppose this is a strip line here, okay, and there is a like there is a gap between them, okay, and they have used wherever they have used diode, they have created a very small strips here like this, okay, like this one as a shorting pin, okay, to connect the shorting pin with the ground to provide the ground, okay, and this one here at this point, sorry, let me change the color. Okay, at this point, okay, at this point and in this point, they are proper doing proper biasing or connecting the diodes here, okay, and they at every moment wherever they use diodes, they wanna use diodes, they create L-shaped stubs like this to achieve the circular pattern of the antenna, okay. If the diode is on, then your antenna will work uh, both as frequency reconfigurable and pattern reconfigurable, and also I mean circular polarization, okay. So they have used small stubs like this, L-shaped stubs, okay, like this, okay. So even you can use these L-shaped stubs, okay. So I will download, I mean I will search again. I forgot where I have used, I mean paste that paper. I will send you, okay.
Okay, all right. Thank you.
So did you understand the concept? I hope it is interesting concept, and I hope most of the people like to work on it. Yes.
In fabrication model, how do you to give the positive and the negative terminal voltage bias
Okay.
pin diode?
Okay, let me check if I have a fabricated design here.
I think I said that you show the one filter design that you have to create a one vias, and that vias you have to feed negative from the bottom side and the positive from the upper side of the substrate.
This is not necessary to like to use ground plane, and I mean let me explain here. Okay, suppose this is your substrate here, okay, you this is your substrate here, and you have a patch here, and you have another patch here, and you are using a diode here at this point, okay, and for the positive and negative actually in that case you need to check where you want to, like this is your positive side and this is your negative side, okay. It's up to you, or even if it is sometimes up to the fabricator or other one, if you are using the shorting pin, then even you can create, I mean to connect two lines, oh sorry, what we say, wires, okay. The first wire is connect with the positive point, and the negative second wire connect with the negative point, okay. You have a function generator here, oh sorry, not a function generator, what is the name, forgot.
DC battery or the
Yes,
power supply.
yes, today I just presented one work on it, and this one, okay. Let me okay, like this. Forgot about this one, just DC supply, okay. We have a DC supply here, okay, and you connect the DC supply at this point, okay. You have a DC supply, okay, and you are giving the positive and negative here, okay. You connect the ground, okay, and you connect this one for a positive, okay, and you vary the values of the voltage here and the current, okay. Yeah, even if you want to connect the wire on the opposite side of the substrate, okay, like because in that case, if you, because in some design you see there is a full ground plane on the other side of the substrate, okay, and in that case you can you will see the whole is the whole, I mean the whole side is the ground plane, okay, whole side is grounded, okay, so you can connect wire anywhere you want, okay, but in the case if you don't have any full ground plane on the, or partial ground plane on the substrate, like if you are using CPW technique, then what you will do, you need to create a very small stubs, or you need to create a very small patch on the other side of the substrate just to connect the shorting pin and to provide the negative point, I mean to the ground of this negative point, okay. Did you
And the other option is that we have to directly give the positive to the feed line.
to the field line?
Yes, that DC voltage to if that is a one transmission line or a feed line, that will be loaded with the different shape of the resonator or the metamaterial in itself. You have to shorten that metamaterial resonator, and I have to put some switch across that resonator on the notch between them. Then what I do?
For the field line, I am not sure whether you can provide both voltage and the other at the same time, because here I am checking the figure. I have fabricated one design, and I will show you here. Sensor, they have the same concept as you are talking about.
Yes, sir.
I need to look for the figures. Where are the figures? Okay, let me.
Only you give some idea that how to I have to put a switch. Then I will not directly give the positive and negative bias to the pin diodes terminal. I have to connect the RFC, then the the DC voltage, then the RF means inductor, then the resistance, then pin diode with the positive terminal, and how to grounding. That is how to shorting the second pin with the negative terminal.
In CST or in after fabrication?
After fabrication model, sir.
Okay, okay. Let me. Yes, I am sending the picture in the WhatsApp group. Okay, and then I will explain and download here. Okay, I have in my cell phone. Okay, I am sending more pictures. Okay, this is my sensor. Okay, here you can see I am using a DC supply. Okay, there are no wires connected, but in this case like this. Okay, so you are providing this blue one is uh, for the positive, okay, I mean to provide VCC, okay, and the yellow one, the yellow wire, sorry, white wire is to ground the this sensor, okay. Here we are using, you can see here this is actually IC, okay, like as a sensor of the pin diode, like of the pin diode, but not exactly the pin diode, okay. This is another type of the diode, okay. And they have used different technique here, okay, because in the IC, this is actually this one I am talking about. Where is this one for the biasing? Where is biasing? Yes, this one, okay. This is IC, this is your IC. Which one? This one, that is center, at the center, okay. This one at this point, okay. At this point, this is your IC, this one, okay, this one. And they have used different techniques like resistor, and they have used inductor and resistor. Where is this one? Yes. Just they created another strip line, very small thin line to connect with diode, I mean with the capacitor and resistor here, okay. And then they have provided the voltage at this point, okay, at this point, okay. And then they have used shorting pin, okay, that is connected with the ground plane, okay. And then on the other side they have let me see, yes, this one, okay. Here they have used the ground plane and to solder the wire of the ground plane, okay, to connect with the VC, I mean with the DC supply, okay. So in this case you need to use a shorting pin to connect with the ground, okay.
Okay, sir.
Okay, if nobody have any other question, we can leave. It's a very lot of time. So the basic idea I have shared with you, okay, how to use, I mean design reconfigurable antenna and how to use diodes, okay. And you can play with CST, you will know much more, okay. Even I did not play much with CST, I mean with the reconfigurable, but I am working on it, okay. I hope I will get more good results.
Sir, one last question, sir. If I have to check the result before the soldering pin diode and after the soldering the pin diode, there is some result variation. I have to not give the external bias. Is there any effect of that pin diode?
You mean in simulation, and you mean simulation and measurements are not in good agreement. There is a main change, I mean difference.
Yes, you have to say that in simulation I got the 100% result for the reconfiguration purpose, switch on, switch off. I have to get the perfect result. But in the fabrication, when I have to measure the result without pin diode, that I have to get the 100% same result as per simulation.
Yes.
But when I have to soldering the pin diode across the fabrications, so that will be the result is some variation frequency. Otherwise, that will be the return loss will be changing. So that
if your design, I mean if your I mean your diode is working, I mean if it is working, then your frequency will shift, okay. Like maybe not exactly as in the simulation, but less than minus 10 dB, okay, at any frequency. It means your diode is working, no any I mean problem with the issue with the diode, okay. But even if you are saying that even there is no change in the frequency and your diode is still not any working, then you need to use the DMM to check the polarization of the diode, okay. You need to check either your I mean the positive side and the positive leg and the negative leg are not are grounded with each other, okay. Sometimes it happens because the size of the diode is very small, and when you solder the diode, all the pins of the diode become grounded, okay. In that case the diode become burnt and it does not work, okay. So you can unsolder and can solder new one, okay.
Thank you, sir.
Okay, we can leave the session, okay, because we already very late and I have to take my dinner.